In this video lecture, I will give you an introduction to organic spectroscopy. What is spectroscopy? Spectroscopy, is the quantized interaction of light with matter. Matter consists of molecules. Molecules undergo changes by falling light on the matter. It gives some information by this interaction, and this information can lead to the elucidation of structure of matter or structure of molecule itself. And it is the basic principle underlying a spectroscopic technique. Okay? Light is basically electromagnetic radiation, consists of many components such as cosmic rays, IR rays, UV visible rays, gamma rays, X-rays, microwave, etc. And these regions can be arranged in the order of their frequency or wavelength and is called electromagnetic spectrum. Actually, electromagnetic spectrum covers a very wide range of electromagnetic radiations, from cosmic rays having wavelength in fraction of an angstrom to radio waves having wavelengths in meters or even kilometers at the other end. Okay? The arrangement of all types of electromagnetic radiations in order of their wavelength or frequency is known as complete electromagnetic spectrum. Okay. Here you can see the pictorial representation of electromagnetic spectrum. Pictorial representation of electromagnetic spectrum, which comprises cosmic rays, which having very high energy, or it has the highest frequency, and then comes gamma rays, X-rays, ultraviolet rays, visible region, infrared, microwaves, and radio waves. Radio waves has the least frequency, and frequency is inversely proportional to wavelength, and hence we can represent the electromagnetic radiation is the arrangement of these regions according to their wavelength, according to their increasing wavelength also. See, as the frequency decreases, the wavelength getting increases from cosmic rays to radio waves. Okay. Almost all parts of electromagnetic spectrum are used for studying matter. In organic chemistry, we are mainly concerned with the three or four regions such as ultraviolet and visible, infrared, microwave, and radio frequency of absorption. See, these different regions gives different informations, and hence we cannot use only one of these techniques for the elucidation of structure of organic molecules, but we have to use one or more different techniques for the complete elucidation of structure of organic molecules. Okay. Now we can look at what happens when molecule absorbs energy in a quantized manner. See, for example, if light is absorbed in the visible region by molecules, usually changes in its electronic levels takes place, and hence often UV visible spectroscopy is called electronic spectroscopy. The wavelength of absorption in the UV visible region is 190 to 400 nanometer for UV, and from 400 to 800 for visible region. If this region is absorbed by the molecule, change in its electronic energy levels takes place, and it gives some information about the molecule, such as extent of pi electron system within the molecule, presence of conjugated unsaturation, and conjugation with the non-bonding electron, such as in carbonyl compounds. That means if you pass light of specific amount of energy as quantum or quantized amount of energy for the transition of electrons from an electronic level, that is from or for the electronic transition, we get some information if it absorbs this much amount of energy in ultraviolet or visible and visible region, such as extent of pi electron system. Extent of pi electron system, that is similarly presence of conjugated unsaturation. If there is any pi electron system, for example ethylene, butadiene, benzene or cyclohexadiene, such conjugation may present in organic molecule. Sometimes conjugation with non-bonding electrons, such as in alpha beta unsaturated ketones, if their presence can be detected or identified by using ultraviolet and visible spectroscopy. Okay, that is one of the important informations given by this UV visible spectroscopy. The UV visible spectra ranges from 190 to 800 nanometer, usually 190 to 400 nanometer for ultraviolet and 400 to 800 nanometer for visible region. If the radiation within this region is absorbed by the molecule, changes in the electronic energy levels takes place and gives some information about the extent of pi electron system, presence of conjugated unsaturation, that means if there is unsaturation is present or not, such as butadiene, hexatriene, etc. And conjugation with the non-bonding electron, if this non-bonding system, such as carbonyl group, if present with a pi electron system, thereby if there is conjugation, such conjugation with non-bonding electrons can be identified using UV visible spectroscopy. Okay. Similarly, if the molecule absorbs infrared region, that is frequency 400 to 4000 centimeter inverse, usually changes in the vibrational and rotational movement in the molecule takes place, and which gives some information such as detection of functional groups which have specific vibrational frequencies. For example, carbonyl group or C double bond O group, NH2 group, OH group, etc. Okay, that is, if the molecule absorbs light of infrared region, that is usually with a wavelength within the range of 2.5 to 25 micrometer, or frequency it is 400 to 4000 centimeter inverse, then changes within the vibrational and rotational movement of the molecule takes place, which leads to some information, which leads to some useful information. We get some useful information such as detection of functional group. We can detect the functional group by using infrared spectroscopy. That is one of the important application of infrared spectroscopy. That is, we can detect or identify functional groups. So, these functional groups have specific vibrational frequencies. For example, C double bond O, NH2, C double bond O, NH2 or OH, etc. Okay. If the molecule absorbs microwave region, that is frequency about 9.5 into 10 raised to 9 Hz, electron spin resonance takes place or electron paramagnetic resonance takes place. That means that induces changes in the magnetic properties of unpaired electrons. That is, the absorption of microwave region, the absorption of molecules of microwave region usually leads to changes in the magnetic properties of unpaired electrons. And this change may lead to some informations, or it is useful for some information such as detection of free radicals. We can detect free radicals if present, and the interaction of electrons with nearby protons. That is one of the important applications of microwave spectra or rotational spectra. It is otherwise called rotational spectra. Okay. Another important region the molecule absorbs is radio frequency region. That is frequency between 60 to 600 megahertz. Usually nuclear magnetic resonance takes place. That means this absorption, the radio frequency region, induces changes in the magnetic properties of certain atomic nuclei, notably that of hydrogen and carbon-13 isotope of carbon. And hydrogen and carbon atoms, may have different environment and can be detected. In which environment this hydrogen as proton or carbon as carbon-13 is laying. By knowing this environment, we can deduce the structure of that molecule. That is what is called Nmr spectroscopy. That can be discussed later. Okay. Another important spectroscopic technique is mass spectrometry. One of the important difference between the mass spectrometry and the other spectroscopic techniques that we had discussed earlier is mass spectroscopic technique does not use the electromagnetic radiation or light. Instead, in this technique, we are using electron beam, an impact of electron beam of about 70 electron volt of energy. That is around 6000 kilojoules per mole of energy. By passing an electron impact, ionization of molecules and fragmentation of molecules into a spectrum of fragment ions are produced. And by using this fragmentation pattern, we can determine the relative molecular mass or molecular weight, and also it is used for the deduction of molecular structure from the fragment produced. That is, and this technique is known as mass spectroscopy. It is different from other spectroscopic technique that it will not use electromagnetic radiation or light, but instead it using electron beam impact of energy about 70 electron volt. Okay. Now let us summarize our discussion. We had seen what is spectroscopy. It is the quantized interaction of light with matter. The information given by this interaction is the basic principle underlying the structural elucidation of by using organic spectroscopic techniques. Then we had seen light consists of electromagnetic radiations, and these electromagnetic radiations are arranged according to their increasing wavelength or increasing frequency, and this is called electromagnetic spectrum. That is the arrangement of electromagnetic radiation according to their wavelength or frequency is known as electromagnetic spectrum. This spectrum consists of many regions starting from cosmic rays at one end and it ending the radio frequency at the other end. Not all these frequency ranges are not utilized for structural elucidation or spectroscopic analysis. Only 3 or 4, such as microwave region, IR region, UV visible region, and radio frequency region are usually used for spectroscopic analysis. By using UV visible region, we can analyze the electronic transition, or by absorbing this UV visible region, electronic transition takes place, and hence often UV visible spectroscopy is referred to as electronic spectroscopy. We can detect the pi bonds present in organic molecule, conjugation if present, or the pi bond is in conjugation with the non-bonded electrons, etc. That is why we can identify alkenes, similarly conjugated alkenes, similarly carbonyl compounds, if it is in conjugation or not, it can be detected by using UV visible spectroscopy. Then IR spectroscopy, in which molecule absorbs IR region, infrared region, whereby vibrational changes within the molecule takes place. By analyzing this vibrational change, we can determine the functional groups present in the molecule, such as whether there is carbonyl group or whether there is NH2 group or OH group. Any functional groups can be detected by using IR spectroscopy. Similarly, we had seen what is microwave spectroscopy. If molecules absorbs microwave region or light of microwave region, electronic spin change takes place, or a paramagnetic electron spin change, and hence this leads to the information about the free radical and the interaction of these electrons with the protons, etc. Okay. Then another important spectroscopic technique that we had seen is Nmr spectroscopy. When radio frequency ranges or frequency from radio frequency ranges is absorbed by the molecule, the nuclear spin changes from one state to another state, say for example alpha state to beta state, as a case may be. Many information regarding the environment of proton within the molecule or environment of carbon-13 within the molecule, which leads to the structural analysis of molecules. That is important. That is Nmr spectroscopy. Another important molecular spectroscopic technique is mass spectroscopy. It is often referred to as mass spectrometry, because in this technique we are not using the electromagnetic radiation or light, but we are using electron beam impact of energy about 70 electron volt. By passing this much amount of energy through the molecule, fragmentation takes place to form free radicals, and by knowing the molecular weight of these free radical fragments, we can determine the molecular structure by analyzing the fragmentation pattern. Okay, these much things that we had discussed today. We will discuss each of these spectroscopic techniques in the forthcoming classes. Okay, thank you for listening.